Okay, so now we're moving on to ellipses, and the key thing to remember when you're graphing an ellipse or dealing with an equation to set up into graphing, this value over here has to equal 1. If it doesn't, then you need to divide every term in your equation by whatever this value is. So I'm going to divide this by 81, and then these two terms, I'm dividing everything by 81. Okay, so this will simplify down to x squared over 9 plus y squared over 81, and that equals 1. And now this equation is in the form where we can graph it. So there's a few things that we're going to kind of calculate and figure out. Okay, so first we need to figure out what A and B are, and the key thing to remember is that A needs to be bigger, needs to be bigger than B, which those both need to be bigger than 0, and they are pretty much always are going to be in these problems. So determining which A and B value are bigger, that tells you which direction the ellipse is oriented, and just so you know, ellipse is sort of a fancy word for oval. So depending on which one is bigger, your oval is going to be shaped like this, or shaped like this. So, and by saying which one is bigger, I mean it's the value associated with the x and the y term. If the value below the y is bigger, then you're going to have this shape. If the value below the x is bigger, then you're going to have this shape. So clearly we can see that this value is bigger than this value for this equation. So we're going to have an oval shaped like this. So to figure out what A and B are, so therefore this one is A, this one is B. So we have to ask ourselves, all right, what squared gives me 81? If you take the square root of both sides, then A is clearly plus or minus 9. And then for B, same sort of thing. Since we're determining, this is actually technically, I'm sorry, those are the squared terms. So A and B, since the square root of 9 is 3. So now we're ready to graph. But it should be noted first that the center for this ellipse is going to be at 0, 0. And the reason for that is because when we're looking at these terms here, this is not something like this. X minus h, y minus k. So we don't have h's and k's in this problem. We'll deal with one that does next. So if you don't have any values associated with the x and the y term, then your center is automatically going to be at 0, 0. Okay, so to graph your ellipse, you first identify where your center is, which of course we already discussed, that's at 0, 0. So, again, as a reminder, if you need to kind of reverse and look back, this A term was associated with the y, the B was associated with the x. So the way you graph these is, starting at your center, on the y-axis, we're going to go plus and minus 9 values from the center. So we're going to have an endpoint here and an endpoint down here. And then for the x-axis, again starting at the center, we're going to go 3 units in both directions. So ellipses, once you figure out what A and B are pretty easy to graph, because this is all you need. So now you just connect to your oval, and hopefully yours doesn't look as much like a football as mine does, but I'm a horrible drawer, so I won't hold it against you. Anyway, so we've constructed the graph. These problems, however, ask for a whole lot of other information. So they ask for the range and the domain, which is much easier to see once you've actually graphed the problem. So we'll start with range, since that's the one I started with. So again, the range is all the possible y values that the graph can take on. So pretty much from endpoint to endpoint are the possible y values. So the range is going to be from -9 to +9, because those are the y values it can take on. Similar thing for the domain, except of course domain refers to the x values. That's the lowest possible x value. That's the largest possible x value, so the domain goes from -3 to +3. Okay, so our endpoints, the other thing they ask for, those are these points here. So those should be relatively easy to pull off the graph. So you'll have endpoints at 0, 9, 0, -9, and then at -3, 0, and 3, 0. And then the last thing it asks you for is the foci, which there's a trick to this. You need to figure out what C is, and luckily there's an easy breezy formula for figuring this out. So C squared is equal to A squared minus B squared. And we've already identified A and B up here. So again, for these formulas, the larger term should always come first. So C squared is going to be 9 squared minus 3 squared, or C squared is 81 minus 9, which of course is 72. Therefore, C is the square root of 72. Whenever you take the square root of something, that becomes the square root of 72, which if we actually work that out on a calculator, that's roughly 8.5. I'm exaggerating, it's 8.48 something or other. So, but in terms of this, you would take, again, your center value for the problem, and then add and subtract the 72. So, and it depends what your major axis is, meaning the longer one. So, again, but since this problem, for this one, we're starting at 0, 0, plus or minus 72, that's roughly right here, and roughly right here. So nearly at the endpoints. I would accept something like this, just identifying the C value. You don't necessarily need to graph it on your graph for the homework problem. Please let me know if you have any questions.